Hello dear students, welcome back. I am Chetan Rajoria from ABES Engineering College, Ghaziabad. I am covering up unit number 1 of the subject Fundamentals of Mechanical Engineering. The subject code is BME 101 or BME 201. So it is the 15th lecture and the last lecture of this series. In this lecture, I am going to take two numerical problems. We will solve two problems based on the concept of stresses, strains, and elastic constants. So let us see what's the problem. So dear all, this is the problem. At an axial load of 22 kilonewton, a 45 millimeter wide by 15 millimeter thick polyimide bar elongates 3 millimeter while the bar width contracts 0.25 millimeter. The bar is 200 millimeter long. At the 22 kilonewton load, the stress in the polymer bar is less than its proportional limit. Determine the modulus of elasticity, Poisson's ratio, and change in the bar thickness. So in this question, the axial load is 22 kilonewton. So let's note down the data. F is equal to 22 kilonewton. That is 22 into 10 raised to the power 3 newtons. 45 millimeter wide by 15 millimeter thick. So the cross section of the bar is 45 millimeter by 15 millimeter. Okay, it is the width and it is the thickness of this bar. So it is the axial view. We are looking this bar along its length. So it is the front view, or you can say the axial view, and it is the side view of this rod or the bar. The length of the bar is 200 millimeter. This is the length of the bar. Bar elongates 3 millimeter. So change in length is equal to 3 millimeter. Bar width contracts 0.25 millimeter. So change in width is equal to 0.25 millimeter. The stress in the polymer bar is less than its proportional limit, because it means that all these processes, the application of loads, etc., everything is taking place within the elastic limits. Means if we remove the load, the bar will spring back or come back to its initial shape, initial length, and initial dimensions. So within the elastic limits, everything is happening here. So we need to calculate the modulus of elasticity, Poisson's ratio, change in length, change in the bar thickness. So first of all, let's use the formula of elongation. Delta L is equal to F into L upon A into E. From this, we can calculate the value of Young's modulus. E is equal to F into L upon A into delta L. Let's put the values. E is equal to, the value of F is 222 into 10 raised to the power 3 multiplied by length. We are putting the value of length in millimeter itself. 200 millimeters upon area. Area, we will put this cross-sectional area. It is 45 by 15. 45 multiplied by 15. This is the area multiplied by delta L. What is the elongation of this bar? The elongation is 3 millimeter. So if we calculate this value using our calculators, we will get the value of E. E is equal to 2172.83 Newton per millimeter square. Or we can say E is equal to 2172.83 megapascal, because Newton per millimeter square is equivalent to megapascal. So it is a value of Young's modulus. We have found our first answer. Okay, A part. Now, Poisson's ratio. For Poisson's ratio, what we need to do? We will calculate the ratio of lateral strain to the longitudinal strain. Poisson's ratio is equal to lateral strain upon longitudinal strain. In this case, when the cross section is rectangular, for lateral strain calculation, either we will use the dimensions of width or we will use the dimension of thickness. Because the change in width is given in this question, we will use the change in width upon initial width as lateral strain. So let's put the value change in width upon initial width upon change in length upon original length is equal to change in width upon original width multiplied by L upon delta L. So let's put the value is equal to, what is the change in width? The bar width contracts 0.25 millimeter. So change in width is 0.25 upon. What is initial width? The initial width is 45. 45. So this is the value of lateral strain upon, what is the value of longitudinal strain? Longitudinal strain is change in length upon original length. It is 3 upon 200. So by calculating this value, 0.25 upon 45 multiplied by 200 upon 3, we will get the value of Poisson's ratio. The value of Poisson's ratio is coming to be 0.37, and it is having no units. It's just a number. So this is our second answer. Okay, it's the B part. Now let's see what is the part C, change in bar thickness. So we already discussed in our previous lectures that lateral strain can be defined as change in width upon original width or change in thickness upon original thickness. The ratio of these two values will, these two ratios will be same. Okay, both of these values define lateral strain. It means that change in width upon original width is equal to change in thickness upon original thickness. So let's put the value. Change in width is 0.25 upon original width is 45 is equal to change in thickness. It is to be found here. It is our objective. And what is the initial thickness? It is 15. From this, we can calculate the value of delta T. Delta T is equal to 0.25 multiplied by 15 upon 45. So this value is coming to be 0.083 millimeters. So that is our third answer. So it was the C part of this question. So in this way, the question has been solved. We have solved all the three parts, the first part, second part, and the third part. Now, let's see one more problem. So students, this is another problem based on the same topic, stress strain and elastic constants. A metallic wire of Young's modulus 20 into 10 raised to the power 10 Newton per meter square, and Poisson's ratio mu is 0.26. The length of the metallic wire is 3 meter and the diameter is 0.1 centimeter. So let us suppose this is the metallic wire, okay, and the diameter diameter is 0.1 centimeter. So D is equal to 0.1 centimeter, that is 0.1 into 10 raised to the power minus 2 meter. Or if we need it, we can convert this value into millimeter also. So in millimeters, this value will be 1 millimeter. This is the diameter. Okay, Young's modulus is given, Poisson's ratio is given, length L is equal to 3 meter. So calculate the decrease in diameter. and we need to calculate the change in diameter. This is the overall objective of this question. The wire is stressed by a load of 10 kg. So one more data is given here. Force is 10 kg. That is 10 multiplied by 9.81, which is equal to 98.1 newtons. This is the amount of force which is acting. So first of all, let's apply the formula of elongation. Delta L is equal to F into L upon A into E. Let's put the values. How many values we know here? Change in length. So let's calculate the value of change in length. F is equal to 98.1 Newton multiplied by, what is the length? It is 3 meters. Let's put the value 3 meter directly. What is the area? The area of the cross section is pi by 4 d square, pi by 4 diameter square, or pi r square. So I'm using this formula for calculation of cross section. This will be the cross section, circular. So pi by 4 into diameter square. Diameter is 0.1 centimeter. That is 0.1 into 10 to the power minus 2 meter and square. Multiplied by E. What is the value of E? It is given in the Newton per meter square. Directly we will use this value 20 into 10 raised to the power 10. Okay. By calculating this complete expression, we get the value of elongation. Is equal to, this value is coming to be 0.0018 meter. So that's the answer. Okay. Actually, change in length is not asked in the question, but we need this value for the calculation of decrease in diameter. Because for calculation of the decrease in diameter, directly or indirectly, we want to calculate the lateral strain. And for lateral strain calculations, we will use Poisson's ratio. Now, in case of Poisson's ratio, we use longitudinal strain also. That's why we have calculated this value delta L. So let's apply the relation for Poisson's ratio. Poisson's ratio mu is equal to change in dia upon original dia upon change in length upon original length. It's equal to change in dia upon original dia multiplied by length upon change in length. From this, we can get the value of delta D. Lies that delta D is equal to mu multiplied by D into delta L upon L. Let's put all the values. Change in dia is equal to, what is the value of mu in this question? Mu is 0.26. 0.26 multiplied by diameter. Diameter has been given here 0.1 centimeter. So 0.1 centimeter means 0.001 meter multiplied by delta L. We already calculated the value of delta L, 0.0018 meter. 0.0018 meter divided by length. What is the original length? The original length of this bar is 3 meters. By calculating this expression, we can get the change in diameter. It's coming to be 1.56 into 10 raised to the power minus 7 meter. And that's the answer. So in this way, this question has been solved. Sometimes it is also asked in the problems that when mu and E is given, in that case, we need to calculate the value of K or C also. K is bulk modulus and C is the modulus of rigidity. For calculating these two values, we will use these two formulas. E is equal to 3K 1 minus 2 mu implies that K will be equal to E upon 3, 1 minus 2 mu. This formula can be used for the calculation of bulk modulus. There is one more relation. E is equal to 2C 1 plus mu. From this, we can get the value of modulus of rigidity. E upon 2 1 plus mu. So it is not asked in this question, but in some other problems you can observe that sometimes this modulus of rigidity or bulk modulus is also asked. So these two values can be calculated very easily using these data, means Poisson's ratio and Young's modulus. Only these two values are to be found. We can calculate the other two values very simply. So that's all for this part. Thank you so much, students. I hope you learned a lot using these lectures. Through this video lecture series, I have covered all the topics from unit number 1, and I'm very hopeful that all these lectures are very helpful for you. Thank you so much for joining. Thank you so much.